Okay, so graphing a piecewise function, there are two ways we can look at graphing. One is using a t-table, which we're going to use values that are in the domain that are listed after that piece of the function. And then once we have points on the t-table, then we can just plot those on our graph. Another way is we can use the transformations of our parent functions, graph everything in its entirety, and then we can go back and erase the parts we don't need that aren't in our domain. Now, usually we see continuous functions. That's when we can draw the entire graph without lifting our pencil. But you may see some discontinuous functions where there are going to be gaps in the data. So these are graphs that we cannot draw completely without lifting our pencil. Now, we may have a special type of discontinuous function which is called pointwise discontinuity, and that's when you have a hole in the graph. And we're going to take a look at that in class with a rational function. That's where we're mainly going to see those. So we'll get to that later on. Going up, but fuzzy, clear. You can tell piecewise graph. Let's take a look at the first part, which is p of x is equal to -4. Well, this is a horizontal line at -4. Well, this is pretty easy to graph. So if you graph in the entire line, here's our horizontal line. And then if we go back to our domain, we only want the pieces from x being less than -2. So if we go to -2 on the x, go down to our graph, we're going to put an open circle here, and we only want the parts to the left. So then we need to go back and erase the parts that we don't need. So there's our first one. Let's take a look at the second one. This is an absolute value function. And we know from the last chapter that this is a V shape, and then both lines have a slope of 1 and -1. The negative out in front means we're going to flip over the x-axis. And then the -2 means we're going to move down 2. So this one's easy enough that we can figure out without doing a t-table. So we're going to start here, down 2, and this part is going to have a slope of +1 as our v, and then this line is going to have a slope of -1 as part of our v. And then we need to go back and look at our domain, and we want to include -2, so we're going to fill in this circle. And then we want to go to +4 on the x, and we're not going to include that, so we need an open circle here. And then we'll go back and erase the parts that we don't need. Okay, our last piece is a square root function. I'm going to use a t-table on this one, so we just need a couple points because we know a square root function, basically what it looks like. We just need to figure out where it is on our graph. So we have x and we have p of x. And let's just start with a value that's in our domain, which is 4, because x is less than or equal to 4. And this is nice because the square root of 4 is 2, which is a whole number. 2 times 3 is 6. 6 minus 9 is -3. So now we have the point 4, -3. And that's going to be a closed-in dot because we're including that. And let's pick another nice number that we can square root. So let's pick 9. 9 is also in our domain. Square root of 9 is 3. 3 times 3 is 9. 9 minus 9 is 0. So now we have a second point, 9, 0. Plot that point, and then we know the general shape of what our square root function is going to look like. Put an arrow at the end, and there we have our piecewise function graphed, our 3 separate pieces. And you can tell that the first part is continuous, but our third piece is discontinuous because there's a gap in the data.